Find the volume of the solid outside z squared is equal to x squared plus y squared, outside x squared plus y squared plus z squared is equal to 9, and inside x squared plus y squared plus z squared is equal to 81. So you could draw what the graph would look like, or we'll just use Desmos to better understand what's happening. So I have Desmos pulled up right here, and it's the same graph and with the 3 shapes. So what you notice is happening is, well, this is happening, but it'll be better to see what's happening if we take a look at sort of just y or x and z, right? So if we just look at x and z right here, we could sketch this out. So sort of looking back from Desmos, if we just pay attention to x and z, right, we'll notice that we have the cones going out like this. We have these cones, and then we have the, so this is 1, 2, 3, 1, 2, 3, right? And then 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. And then we have a second sphere coming out like this, right? So this is what we're dealing with. We're saying the area outside z squared is equal to x squared plus y squared. So we're looking for the area outside the cone, outside the sphere with radius, or not radius, with rho equaling 3, right? And going outside the sphere with rho equaling 9, right? So this represents rho is equal to 3, and then this represents rho is equal to 9. So we are essentially finding this area right here, right? And it's across the whole, around the whole in a 360 manner. So what we're going to do is we're going to set up a triple integral to find this volume. So set up a triple integral, right? And obviously 1, and then rho squared sine phi d rho d phi d theta. So rho is going from 3 to 9, right? So 3 to 9, because to prove this, x squared plus y squared plus z squared is always equal to rho squared, right? So then that means that rho is equal to 3 right here. Now for this one, this right here, x squared plus y squared plus z squared, we could just write rho squared is equal to 81. That means that rho is equal to 9, right? Rho is equal to 9. Rho is equal to 9. So then 3 to 9, right? Now for this, for phi, right, it's going to be important to look at this, and, well, we obviously know that this is a pair of cones, so the angle that it makes is always going to be pi over 4. But if this wasn't the case and this cone was a bit different, we could just plug in points and use the tangent function to find the angle, but we don't really need to do that here because we know that it's just y is equal to x, right? So then this is going to go from pi over 4, right? And then, so if you look at the unit circle, it's going to go across, which means it's going to be 3 pi over 4. Now, d theta is always just going to be from 0 to 2 pi because we're finding the area, or the volume across the entire, in a 360 manner, right? So now let's evaluate the integral. Let's start off with the first part, right? Rho is equal to 3 to 9 from, and then rho squared sine phi, and then d rho. So this would be 3 sine phi from 3 to 9, which is just equal. So this would be 243 sine phi minus 9 sine phi. So 243 minus 9 is 234, right? So now we're going to do this next part, which is from 3 pi over 4 to pi over 4. 234 sine phi d phi. This is going to be negative 234 cosine phi from pi over 4 to 3 pi over 4. If we look at our unit circle, right, this was going to be pi over 4, 3 pi over 4. Right here, it's going to be root 2 over 2, root 2 over 2. This is going to be negative root 2 over 2, root 2 over 2. So negative 200, so 3 pi over 4, at 3 pi over 4, cosine of 3 pi over 4, it's going to be negative root 2 over 2, but that's going to be positive since we have a negative right here. So it's going to be positive 234 root 2 over 2 minus, and then here cosine of pi over 4 is just normal root 2 over 2. So then it would just be minus negative 234 root 2 over 2, right? So now this becomes 234 divided by 2 is 117. So 117 plus 117 is just 234. And now we just do the last integral, which is from 0 to 2 pi, 200 and d theta, which is just 234 to theta from 0 to 2 pi, which is just equal to 468 pi. And that would be the answer to this problem.